Login accepted.
I'm sorry, even I'm like a little bit late, I couldn't find the room. And thanks to Daniel from Red Hat, who was here as we were trying to find the room, and I finally found it. So, yeah, it's a big place, and thank you so much. Thank you. Okay, great. I can see it now. So rather than delaying any further, I know folks are still coming in. I'm just going to start talking a little and then start when it seems like if the crowd kind of slows, coming in, slowing down. So, okay, so welcome everybody to my talk. I know I'm like the first session after Ted's keynote this morning. So really great to be back for me for the second time to be in Devoxx, Poland, and I just love your city. Krakow is one of my favorite cities in the whole world. It's just really great to be back. It's always so exciting, and then being back at Devoxx in person. So this has been great. So thank you everybody. I know you have other talks to go to, but for you to come here, thank you very much. So my talk today is on event streaming and processing with Apache Pulsar. May I ask you how many of you have heard of Pulsar, Apache Pulsar? I'm trying to see. Yeah, maybe very few. I don't see many. So it is a bit of a newer, not that new, but I will be introducing to you, but not as well-known streaming platform, distributed messaging streaming platform. And I'm sure a lot of you probably, if you're working with messaging systems, you're probably working with Kafka. Am I correct? Maybe I'll just want to ask if anybody's working with Kafka. Yeah, okay, so I can see quite a few. So I can also imagine too. So again, I feel like I'm coming in here not like saying that we're gonna knock down, Kafka, even though I think the creator of Pulsar is trying to say so. But the thing is, I look at it, it's more like an extension of Kafka. So this is what Apache Pulsar is mainly about at this point. So that's what it is. So, okay, so I think I probably should formally start now the talk, even though I'm still seeing some folks coming in, so pardon me if I'm going to start now. So you're here for the talk on Apache Pulsar and also about event streaming and processing. And my name is Mary Grygleski. I'm a streaming developer advocate at DataStax. The company is based in California, Santa Clara, and if you work with Cassandra, you probably have heard of them. They have we have our managed Cassandra platform called Astra. So Astra DB, and then there's also Astra Streaming, and that's where Pulsar comes in too. And so this is how you can get in touch with me, but I'll have more information about myself afterwards too. Towards the end of my slide deck, I have like resources and links and all those things. So thank you again for coming to my talk, and let me start now. And if you are interested in following along and you would like to have the slide deck, I don't know if you can kind of quickly get it. If you're interested, you can also, I don't know if you can actually from a camera to get the QR code, but I have it up here if you want to follow along. Otherwise, too, I will make my slide deck available too afterwards. So, okay, that's that. Okay, first of all, let me also, again, a quick introduction about myself. I'm a senior developer advocate at IBM. It's about open source software that we support, Apache Cassandra, and then Apache Pulsar now with the streaming side. Previously, I was with IBM. I was with the Java advocacy team for 3.5 years before this. I'm based in Chicago, and I'm also a Java champion and also president and executive board member of the Chicago Java Users Group. So I like to also encourage you, if you are not already involved with any user group, please join. I think it's always, we have good intentions of bringing technology and sharing of knowledge to the community, and you can help too. And that's also a good way if you decide to become a speaker. And I think Java Users Group is a good way. You can go and do presentations. There are lightning talks, for example, and you're welcome to join ours because we're still doing live stream too, even though the time zone may be different. But we try to also accommodate European speakers too. So we may have some meetups that are suited for your time zone as well. So. Okay, so my background too, I have over 20 years of experience in doing Java development before becoming a developer advocate. So, and I love my job. I just love meeting folks like yourself, and because I also have been in the trenches, right, so to speak, doing development work. So I understand too the challenges we face as developers, especially in a business world, in a production environment. So this is just another slide deck, and all these that I've worked with, and also my different links as to how you can get a hold of me. So, okay, so let me start. So today's agenda, I'm going to first start off with some basic kind of introductory kind of concepts to talk about event streaming, about distributed messaging, event processing, and complex event processing, all these things. I feel there's a need to kind of put us all on the same page before I start actually getting into the details. So I hope it's okay for some of you if you're already familiar with this. As such, too, even when I first started doing Apache Pulsar, I was also mixing like streaming with event messaging, all of these things. So I want to kind of clarify all of these terms first. And then also bring in the semantics aspect of messaging, which is essentially pub/sub and queuing, too. And then I will get into talking about why event streaming. And then I will introduce you to Apache Pulsar, and also its dependency on Apache Bookkeeper and Apache Zookeeper. And I will highlight a few developer features in Apache Pulsar. And also talking about why Pulsar. So it's trying to extend what Apache Kafka perhaps not as capable of doing, given the cloud-native world that we are living in now. So, first of all, the many facets of computing events. So let's just kind of get down to basic, really basic is, what is an event, right? Generically speaking, meaning that, it doesn't matter anywhere you go, events. And in fact, when I submitted a proposal to a conference and the organizer came back, and this person is not actually a technical person. So that person was asking, oh, event, are you referring to like something like a concert, right? Going to that is event, which is true, right? So I look up the Merriam-Webster.com dictionary and look up the proper definition for event. So it's about something that just happens, an occurrence. So likewise, too, in computing events, we're really talking about, if you want to express events in terms of mathematical model, then you would be talking about the XYZ coordinate, so the 3 coordinates of place. But with events, too, processing, we bring in the time element. So it's sort of, then we bring in the theory of relativity. So I found the number 4 definition of event really is relevant. It's essentially events, they represent, it's like the fundamental entity of observed like physical reality represented by a point in this XYZ coordinate. And also with the time too. So as you can see, events keeps changing. So it brings with it a lot of challenges in doing computing stuff, as we all know. Concurrency, how do you deal with all the data, all of the changes. And that's the thing too about events. We can kind of talk on simpler terms about events, and we're doing pub/sub type of things, right? For example, that semantics of publish, subscribe. So that's simple enough to say, okay, an event happened, you publish it, and some subscriber is interested in the event, will subscribe to it, and you get the messages. That's simple enough. But we live in a world that we're dealing with, billions and trillions, petabytes of data these days. So that's when streaming comes in. The streaming part, to me, it's kind of a step up from just doing the plain old events, the plain old event messaging. Messaging part is kind of like the basic element of enabling streaming to happen. Streaming is the step up to kind of bring all of these events together and processing them and synchronizing all of them in a very coherent kind of fashion. So that's what kind of events, the kind of events that we're talking about with this context in the computing world. So first of all, event streaming and processing. Basically, is when I talk about events, we're really taking action on a series of data points that originate from a system that continuously creates data. And the event, again, it refers to each data point on the system. And the stream is referring to the ongoing delivery of those events, and there can be many too, and you need to make sense out of them. You need to synchronize all of the activities, and if something happens, it needs to trigger another action on it, that type of stuff. So as such, this series of events can also be referred to as streaming data or data streams. And then there's also the term of complex event processing. As such, complex already brings in this notion of something complicated. So it's really a set of techniques for capturing and analyzing all of these streams of data as they arrive. So the streaming part is more like mechanical, but the complex event processing is what you bring out the value of the data that you're trying to process from the streams. So as such, right, complex event processing would be analyzing these streams of data as they arrive. And why do we want to analyze it? Because we want to bring out the value of such, right, to identify opportunities. Or some system, right, when you are monitoring fraud, kind of fraud detection system, those are best to rely on a streaming type of platform because it brings out that real-time kind of processing that you can have. You don't want to wait, if somebody is committing some crime on your data, you want to know it right away. So that's why we want to go the event processing, event streaming kind of route. It brings in that real-time aspect of processing data. And so complex event processing enables your system and applications to respond to events and trends. And then also, not just with fraud detection. For example, you are doing online shopping. You want to be able to do machine learning type of algorithms. You want to apply that right away and analyze somebody's shopping patterns, as they click through a site. You want to make recommendations. So that's the goal of doing event processing. You give a much more satisfying end-user type of experience. So that's complex event processing. Now, we get into a bit more into the nuts and bolts, kind of like the basic parts of doing streaming. I go back a bit to messaging. So there is also event-driven and then versus message-driven messaging. Event-driven, essentially, it's more about the pub-sub type of way of doing things. You involve a sender and a receiver, or a publisher, subscriber, or producer, consumer, however way you want to name it. It's always multiple parties, but actually the difference is event-driven involves one-to-many. So basically, the one that's producing data really doesn't quite care about who's going to need the data because it's up to the receiving side. If the receiving client is interested in the data, that client would need to subscribe to the topic in order to receive data when it gets delivered. So that's event-driven, so one-to-many type of scenario. And then there's also message-driven type of messaging. Message-driven involves actually knowing each other. The sender and receiver is always point-to-point, like kind of one-to-one, and the address would need to be known in that case. So that's message-driven. And also, just want to point out to this definition, too, I also double-checked, so just so you know I'm not talking something, kind of out of the blue. It's from actually Lightband, their reactive manifesto, and as you may be aware, Lightband is the company where Dr. Martin Odersky is, where Scala got invented, and Arca system, and all these things. So they really kind of bring the reactive manifesto, the reactive stuff, to kind of like the really a high level of definition. So I really like their definition. It's really event-driven and message-driven. Those are the differences. And now let me kind of also then bring in another aspect, right? And we're talking about event approach. So what is the other way of doing things? So essentially, it's more like batch processing. So if you look at events, that's the thing too, is everything happens and you analyze it right away. So the difference, the opposite of such would be batch processing. So you gather a bunch of data points, right, and changes in your data set or database. All those changes, you capture it during the day, and then you want to batch them up and process them at a later point in time. The benefits is that you don't take away computing power during the bulk of the day when you need to be addressing more interactive needs of your systems. So batch processing is what's kind of like opposite. And also, too, batch processing is placed in computing world, too, because you want some data, too. For example, you make changes. Let's say you are a subscriber to a frequent flyer program. You make changes to your data. As we all know, sometimes these data don't get updated right away because they are being processed in batch. It may be nighttime when the rest of the world is sleeping, then you can process all of these changes. That will probably take a lot of time to kind of process too. So that's kind of opposite of doing events, kind of is batch processing. And now let's kind of look into the event messaging semantics and patterns, which I already kind of talked about, which is like doing streaming. It's enabled by using a pub/sub type of approach. So publishing client will send the data, and send the data to who? So basically, you always involve a middle agent, right? Middle person. I would not want to name like gender. So middle person, an agent. So that's the broker. The way I look at it is sort of like a post office kind of person, right? Postmaster in there in a post office. So if I'm there to produce data, the publisher will then send the data to the postmaster. And basically, it doesn't care about who's going to receive it, but I will need to label the data too. So I give it a topic name for the data channel where I'll be publishing data to. Sort of, it routes the data for you, so the broker knows who to receive. Because then at that point, once you send your data to publish to a topic, then it will be up to the client, the subscriber side. The subscriber, if they're interested in the data, they will have to subscribe to that topic or the channel in order to receive data. So that's also the differences of when you compare pub/sub to traditional programming, like request response. In this case, too, you do pub/sub, it can happen at any time. You can be already a subscriber, but you don't get any data until data gets published to that topic. Whereas for request and response, as we all know, there's a wait time too. Is that, say, for HTTP type of communication, then you send a request, you essentially have to wait for the data to come back to you, right? So that's more kind of a difference between that and like pub/sub type way of doing things. So another way of doing kind of asynchronous style of processing would be using message queuing. It's much like message-driven messaging that I talked about earlier. Message queue is again, enables service-to-service communication, and is mostly used in serverless and microservices type of architecture. So messages are stored on the queue until they are processed or consumed, and then they get deleted too. But each message is processed only once and by a single consumer. So that's message queuing. And it can be used to decouple heavyweight processing to buffer or batch work or to smoothen spiky workloads. So it has its own needs too. So I'll kind of bring up the fact that Apache Pulsar, it actually has a broker, but it also enables, or you can also do message queuing with Apache Pulsar too, because there are different modes of messaging subscription that you can do. So I'll kind of talk about that. And so that's kind of another unique feature of Apache Pulsar, supporting both pub/sub and message queuing. Okay, so with that, I'll just start a little bit. Although let me talk about then why event streaming, we get into it, right? So what is driving the change? So essentially, we have a demand for real-time data. So real-time data, again, I was explaining about fraud detection or shopping experience, you want to make recommendation. It gives you an enhanced customer experience when you can get your information back right away. If you have something that happens, then you get some guidance to you or a recommendation of fraud, you detected some kind of criminal activities on your data, that type of stuff. So it's a real-time enhanced customer experience. And then also, too, using streaming, you can actually use it for example, to develop your data pipelines, right? So data pipelines, which I will describe in a little bit too, is basically to help you to build like artificial intelligence or machine learning, ML ops type of pipeline, and allows you, to kind of like or enable you to process these data changes and capture them and then make immediate decision. And especially, for example, in ML ops, if you're involved with machine learning, that's the difference from DevOps, because DevOps, you're just more like writing the code and you do certain sequences of events one after the other. But ML ops, you have data coming in, you need to constantly deploy it to production, and you study that data and then comes out with you have to update your algorithms in real time. So using a streaming data approach is actually the way to go. I think right now there are not that many ML ops actually using streaming yet, but there have been a lot of talks, and also some companies are already encouraging that too. So there's like a big prospect for event streaming to kind of become the mechanism to enable ML ops. And then another thing is with Pulsar, this type of event streaming system is that it helps you in scalability. You can scale really, as you can see, if you use a Pulsar type of scenario, you can have one producer producing messages, and you can have essentially millions and trillions of customers or clients subscribing to the data to be received, to get the data as well. So it really helps in the scalability aspect. So those are kind of reasons for doing event streaming. So this one I already kind of talked about it, but essentially too is basically allow you to use events. The benefits of event streaming is that it allows you to make decisions on data in real time, not after the event. So that's the significance of using event streaming. And now let me then introduce to you Apache Pulsar. So what is Pulsar? It is an open source project that's now part of the Apache Software Foundation. So there's a formal PMC that's governing it, and the whole project is within ASF, and then there are contributors from outside company or different companies to work on it. It's actually created by Yahoo back in 2013-14, that time frame. At the time, they were actually trying to use Kafka, but realizing that Kafka was, I think in my mind, as I'm studying this, is more designed for doing messaging. So messaging has its place, right? It is complicated enough. But the thing is, we are starting to move into more of the cloud-native world. So you have to handle data, parallel streams, and running in clusters, and all of these complicated infrastructure. So Yahoo, at that time, the development team realized that the Kafka couldn't meet their needs to handle some of the Yahoo finance data, all of these Yahoo services. So they started developing Pulsar. It's kind of, basically, I call it like Pulsar was born with the cloud-native DNA, right? Because it takes into account that I need to design a messaging system that can run very well in a cloud-native environment that's clustered, that can handle multi-tenancy, geo-replication, all of these things. So Yahoo developed it, and then in 2016, after 3-4 years, they donated it to Apache Software Foundation. In 2018, within a short, less than 2 years, it already became a top-level project because it does have a lot of the features that's desirable by a lot of today's, messaging kind of systems. It has a very native, cloud-native design. It's cluster-based and it's multi-tenant-based. And also, it supports all kinds of client APIs. So primarily, it's still Java, but it also supports C#, Python, Go, and there are also community contributions, such as like Scala, Ruby, and other languages too. So the one thing about Pulsar is interesting is that, which maybe we never thought of, is that when we're doing large event streaming kind of platform, we also, not just we are publishing messages, what to do with the messages, right? So you deliver it or something. You need to have a way, these are like think of it like logging, right? All of these logging messages needs to be saved somewhere. So, and that's the difference, is that Kafka manages its own logging too. So that's why it kind of makes it a little bit less capable of being scalable. However, for Pulsar, because it knows that, well, doing logging, all of these things is like bookkeeping. It's very complicated. So I'm not going to do it. I'm not going to do this work. Let me delegate to someone. So that's Apache Bookkeeper that's handling all of the storage side to manage all of these distributed logging. So it separates out the compute and the storage part. And then another thing about Pulsar, just like a lot of messaging systems, is that message deliveries are all guaranteed too. It supports like quality of services, if you're familiar with that. QoS 0 is like fire and forget, but QoS 1 is guaranteeing your messages gets delivered at least once, and then QoS 2 is exactly once, right? So those QoS. So Pulsar Broker has that mechanism too. And then there are also other message delivery specifics like retaining messages or last will messages, all those things are also supported by Pulsar. And then also there's this framework is basically enabling like lightweight serverless functions type of framework functionality. So much like if you look at Azure has, I think Azure has, what is it, serverless messaging, right, or functions. And then there's Google, also Google Cloud Functions, and Apache, I think, not Apache, AWS has, is it Kinesis? Oh no, that's And anyway, you probably know what I'm talking about, AWS. I just suddenly slipped my mind. It's the AWS. So it gets inspired by those serverless kind of function frameworks. So Pulsar also has the functions framework too. So you can write small piece of processing logic as the data is traveling through your data pipeline. You can actually make changes to it quite easily without relying on any external kind of library to do it for you. So, and then also too, it has a tiered storage offloads, meaning that you can have data that is like in hot and warm storage, right? So you're doing a lot of things, and then when the data kind of cools down, right, it's kind of more data at rest at this point, then you want to basically offload it to a cold storage, that type of stuff. All of these kind of more infrastructural work that's required of any like heavy processing systems like Pulsar. It also kind of has mechanism to handle like moving data from hot to cold for you too. So as developers, we in general don't want to deal too much with the infrastructural things. So Pulsar is designed well enough that it has those kind of capability to help you to do that stuff. So, okay, so again, let me summarize then. What is Apache Pulsar? It's essentially a unified distributed messaging and streaming platform. It's open source, originally developed by Yahoo, and now like part of the Apache Software Foundation, top level since 2018. It's very much a cloud-native Kubernetes. It runs in Kubernetes. If you actually have older systems, let's say you're still running JMS, running any RabbitMQ, for example, and you don't want to change, even Kafka, you can actually put on Pulsar as kind of a bolt-on kind of solution as well. It also supports like multi-cloud and hybrid cloud kind of a scenario too. Okay, so as you can see too, a couple of graphs I'm just sharing in here is basically about number of GitHub stars and contributors. As you can see, is slowly growing over time. And these days too, even with the number of contributors, the open source contributors to this project has outgrown that of Kafka as well. And then you may be wondering, who else is using Pulsar? So just a quick note, I don't mean to be like a marketing person here, but I think it might be helpful to know that, okay, Yahoo is still using it, Comcast and a lot of companies are also in China that are using it. And then there's also Splunk and Verizon, for example. So all kinds of industries, companies are already learning more about Pulsar and starting to adopt it too. Now, so let me kind of talk a bit more now about Pulsar. So it is different. So basically, there are different components, so to speak, right, if I want to highlight what is in Pulsar. So you have a producer, right, and it's essentially the client application sending messages to topic that's managed by the broker. As I kind of describe it, it's like a postmaster. Broker is like that. It manages all of your data and receiving it and also distributing it. So sort of the middle person. And then there's also consumer. So both are kind of considered client applications, right? But one does the producing side, the other does the subscription side is the consumer. And then there's the broker. The broker itself is a stateless process that handles incoming messages, and it dispatches messages, and it communicates with all the other Pulsar configuration stores. So think of it more like a centerpiece of functionality there to kind of direct routing and everything too. And it communicates too with the bookkeeper instances and also the configuration, and also works with Zookeeper because Pulsar uses Zookeeper for helping with like managing all of the cluster, metadata, and coordination tasks between Pulsar clusters as well. And then I also kind of talk about Bookkeeper. Bookkeeper helps with persisting all of the message store. Bookkeeper itself is a separate project of Apache. It also gets to be quite complicated as well. And let me kind of go into the next slides. I have a little words about Bookkeeper too. But first of all, let's then take a look at the design principle of Pulsar. It is a tiered architecture design, and it takes on this traditional multi-node architecture. So as you can see in the diagram, there's producer, consumer, and then there's also the different brokers. So you can have multiple brokers within your Pulsar kind of environment too. Broker, again, will be the centerpiece of serving all of these needs of your whole system. It's kind of act as the centerpiece. And it coordinates with the bookkeeper, the storage side, right? The storage actually can get to be quite complicated in a distributed messaging logging system. You're dealing with billions, trillions of data, all of these things. So essentially, Pulsar doesn't deal with that and let bookkeeper does its job. Its job, broker, is to coordinate with bookkeeper. So, and if you talk about it, right, there are common challenges in kind of cloud native environment. Before cloud native is probably not as complicated when you're dealing with messaging system, but with cloud native, then you have to really start to think about the fact that what if you need to scale your system? You need to increase the number of brokers in your system while your system is in production. So that's where Pulsar comes in and being a strong kind of contender in this space because no one else is doing that. It actually can help you with doing the rebalancing of all of your partitions. So think of all of your topics as being all partitioned on different instances, right, of your, of your broker. Then if you need to add another broker, then what do, right? So you need to rebalance this whole thing. And normally too, right, let's say if you're using a messaging system like Kafka, then you have to actually do a lot of things by hand, right? So manually, kind of, you have to do your own way of managing the rebalancing. But Pulsar itself, you can actually start off without worrying so much about how many topics you need, how many partitions, all of these, because by default, it knows what to do. And then if you need to scale it, actually, it also does have that capability of doing all of the rebalancing for you too. So that's kind of like another really big kind of advantage of using some platform like Pulsar. And so again, right, because it doesn't tightly couple all of your persistence and message serving capabilities, so it kind of makes everything work a lot more efficiently too. I mean, think of the fact that sometimes I like to sometimes use the analogy is that if you live in a big house and you don't want to spend all your time doing all the cleaning, so you hire a cleaning service or somebody that comes into your house and do all the cleaning. It's kind of like same kind of mentality, right, or design in Pulsar. Basically, you delegate some of these more tedious work, so to speak, and to other people to help you, or other libraries in this case to help you. So that's the thing about Pulsar. And again, another slide just going a little bit into it. So I just wanted to point out, broker I already talked about, and what's the big deal is basically help you with horizontal scaling. If there's any kind of disaster recovery situation, because it's already clustered, it should not have too much of an impact. If one node goes down, one cluster goes down, you have other cluster to come up to kind of cover for it. So it's already well designed in a cloud native environment. And the thing is, I wanted to point out here in this case is the bookkeeper, the bookie, and then that's what it's being named as. So bookkeeper is very scalable, and it's also wall-based. So wall stands for write ahead logging is a specification. So what it does is basically helps with every write. Okay, so if you think of, okay, we have distributed logging, we can save it to persistent storage or to databases. But actually, databases doesn't guarantee you the atomicity, right, the atomic quality of making sure data is only write once and then it doesn't change all of these things. And database doesn't have that strong support for this aspect. Whereas like for a wall-based, it basically it leverages on a separate persistent storage. It logs everything first before it writes to persistent storage. So Bookie already handles that aspect for you. So you can safely rely on Bookkeeper to make sure that all of your log messages get saved properly to persistent storage. And it offers kind of fault tolerance and low latency, all of these things, right? And some of these things I haven't gotten into too. For message replication, it gets very complicated. For like all of these ensemble size, write quorum, ask quorum, all of these things, if you are into that, it actually, Bookkeeper is designed to handle that. That's its specialty. And if you need to configure any aspect of it, you can do so through Pulsar too. Pulsar also has a command line, Pulsar admin, where you can also tune all of these parameters too. So I won't get into all the details of Bookkeeper because our session is about Pulsar. But the thing is, too, is that Bookie too, is essentially a complex computing system for doing journaling and ledgers, kind of like you doing accounting. So it has all of these automation in there. So just wanted to point out it is a very robust system that Pulsar relies on for doing bookkeeping. And again, just to summarize, is that Apache Pulsar solves the problems of bolt-on. When I mentioned about earlier, you can be running Kafka, you can continue doing that, JMS or RabbitMQ. You can kind of bolt on Pulsar too. It is a unified solution for doing PubSub, and as I mentioned, it also supports queuing too, if you want to do that by using an exclusive subscription mode for your messaging. So that's what it is. And then streaming and also doing message mediation and enrichment through the use of Pulsar functions. Out-of-the-box capabilities will include like cloud and on-premise, hybrid and geo-replication, multi-region support, all of these things, and data lake if you're into data, data lake and data warehousing, that type of support too. And the matter is that right now, Pulsar is still growing. There's still increasing number of people contributing to the code base too. And anybody can join it too if you're interested. So, okay, so this one, I think I already talked about it. It's just more like a repeat, so I won't spend time on it, but just wanted to highlight too some key differentiator. So first of all, Pulsar has this separation between the compute and storage, as I mentioned to you. It doesn't manage all of the storages of all of these distributed logging. It relies on Bookkeeper to do it. So it makes it, the horizontal scaling really efficient in that case. Number two, so the differentiator is about the geo-replication. And because it is already being, kind of thought of, all of the cloud-native scenario, it actually helps to support. It has also built-in capability of managing your clusters running in different geographical regions. For example, there are different data compliance needs in different regions of the world. Here in Europe, you have GDPR, for example, and so maybe certain data you need to configure it differently. But because Pulsar already is taking account into all of these considerations, it becomes not a too complicated job if you need to configure in a big corporation. You need to configure your data a certain way for certain regions. It can be done easily through configuration. And then another capability it has that's differentiated is about the multi-tenancy. So in any kind of like cluster environment, it gets very complicated. But the thing is, it supports this multi-tenancy concept. Think of it like an apartment building. You have different units, right? And they each are self-functioning. So likewise, and that's how kind of Pulsar works, is that it already has built-in multi-tenancy. You can have different units operating on its own, but the whole thing combined together is under the whole system too. So that's kind of, in a nutshell, that's what multi-tenancy is. Okay, I just need to make sure I don't miss something, or I may be rushing a little bit because there's just a lot of information I still would like to cover. So this fourth differentiator is basically the very flexible message processing model. So as I mentioned too, Pulsar also can support queuing. So that's the thing. If you look at it, there are essentially four different modes of subscription that you can have. First of all is an exclusive mode. So what it means is that in your subscription, you only allow one consumer. So in a sense, you make it into a queuing system. You basically have all the producer. In fact, you can actually have the same subscription for multiple topics too. But in this particular case, you can actually, if you want to do queuing, you basically have one-to-one kind of relationship in your subscription and only allow one consumer. So that becomes a queuing kind of capability in Pulsar. And then there is also another mode, it's called failover. So essentially, you can have two consumers. So if the primary one doesn't work for some reason, goes away, then you can rely on the second consumer to kind of take over. It's kind of a failover mechanism. And then there's also a subscription mode called shared subscription. So you can have multiple consumers for that particular subscription too. It's basically, that same subscription, but you can enable multiple kind of receiver, like in that case. And then if you want messages to be delivered, you want to keep the order, then you can use a key shared type of mode, as you can see like the 4 different modes in here. So. Okay, so that's Pulsar. And here, just wanted to kind of reiterate as to why Pulsar, why do we want to use it, right? So it is basically a very cloud-native ready streaming platform that's kind of already kind of next generation, gives you that next generation capability, right? It can act as a distributed log like Kafka, but it kind of goes a step beyond. It's about this cloud-enabled capability. And also, it's even better than a pure messaging system, for example, like RabbitMQ, because it really takes into account the cloud, the multi-tenancy needs of any kind of large systems. And all of these other things, I already repeated it, so I won't go into all the details, all of the features. But let me highlight a few Pulsar developer features too, which I think as developers we're interested too. First of all, right, when we talk about Pulsar, even though it's streaming, we're really working with data. So as we have all heard about, right, the data pipeline, So essentially, it enables you to build this pipeline. So as you can see, it gets to be very flexible. Think of it like Lego pieces. You need to use different pieces and kind of tie them all together, and then let the data kind of flow through. So that's the data pipeline. And I'm just using an illustration. It's like, you have an input, the source, or the topic in this case, right? The data will travel through the pipes, and basically into like a diagram in here I'm using. It's basically looks a bit more complicated. You have the pipes, and then you have different pressure gauge and doing different things. So that actually is reflecting some capability. You can kind of transform your data or do any remediation to the data. So I kind of describe this diagram, this third one, as sort of like the function that's providing to you by using Pulsar function that you can help you with transforming the data. And then at the very end is that, this is only one pipeline. So essentially, you can have multiple pipelines within your application too, that's all chained together. But each pipeline will have a source, and then Pulsar does all its thing in the middle there, and then output all of these data, the transformed data, into a sink, right? So that's what essentially it is the data pipeline. Okay, and here. So Pulsar function, so what is it, right? Let me kind of get a bit into it. It basically allows for complex streaming processing kind of needs. Very lightweight too. Its function, essentially, is a function as a service type of concept. It's inspired by, that's right, AWS Lambda. For some reason, I thought of Kinesis, but it's actually Lambda, right? And Google function, all of these. And it's kind of inspired by that. You can write small pieces of processing logic, plug it into your pipeline, and it will do all the message transforming for you. The main languages it uses right now is, at this point, is only Java, Python, and Go. But I believe there are community contribution in other languages too. So as you can see over here, in the diagram, you have multiple input topics, right? And input messages get through to the Pulsar functions. It transforms it, and it outputs can be to another topic or another sink. And then you can also continuously build all of your pipelines into more complex kind of sequences of processing too. So. Okay, and then another feature about Pulsar is that, I've been just talking mostly high-level stuff, but the fact is, as developers, we also have to think about when data is going to be sent over the wire. So in general, too, you can write your own serialization and deserialization, but the thing is, if you do not want to worry about doing all your serialization, deserialization, you can also rely on this feature. It's called Pulsar schema. So it kind of takes away some of these kind of boilerplate code, so to speak, to do all these serialization thing for you. So you can use Pulsar schema. So the different schema type that it supports is a built-in schema registry. So it supports like primitive data, like Boolean, integer, 64, 32, unsigned, all these things, right? And Boolean, all these things. So, and then you can also do key value pair. Or doing like, schema, a bit more complicated would be doing Afro schema or JSON and protobuf as well. So these are the different schema types it supports. So in this case, too, if you write code like that, then you don't need to worry about writing the serialization part. By default, too, Pulsar will look at all the data as byte arrays, is what it is. And then you have to do all of these serialization, deserialization yourself otherwise. So with schema, basically, too, schema has an evolution. It also supports different version of it and different compatibility, too. And you can manage the schema is either automatic or manual as well. So if you're interested, you can also look into the documentation that gives you more information about that. And then there's also another feature. It's called Pulsar I/O. So basically, I talk about the sink, right? So a sink is a place where you receive, the data after it's been processed. And every time to a data pipeline, you have your source, and then in this case, Pulsar in the middle doing all the stuff for you and output all the data to a sink. The sink, though, we have already some prefabricated kind of sinks. For example, Elasticsearch, there's already pre-made sinks that you can make use of. Or not just that, there's Cassandra data sink too, JDBC, like PostgreSQL sink and all these things, even Kafka sink, and they're already there. But if there's some kind of library that you want to write your own connectors, you can basically use Pulsar I/O to do that too. We have a series of classes where you can actually write your own as well. So, but I don't have time today to kind of get into all that detail, just want to highlight to you. But if you're interested, let me know. And I also do a weekly Twitch stream, by the way. Sometimes I take all of these and then work on it on my Twitch stream, so you can join me there too. Okay, so at this point, the last couple minutes, just wanted to bring out to is my company, DataStax, right? So we support Apache Pulsar. So just want to point out to you. So we have actually what we call like Astra streaming. So it's a managed Pulsar platform. So if you're already familiar with Astra database, that's the Cassandra managed Cassandra on the cloud. And in there too, we have added in Astra streaming, which is the Pulsar capability in there. And then if you want to manage your own Pulsar, you can actually use Luna streaming too. It's a bit more manual too. A lot of the things, there's no console for you to manage it. But you can use it for free. If you need support, you can kind of pay and then get enterprise support too. Now, if you're an open source person, you can always use the open source Apache Pulsar as well. So there are different ways of using Pulsar. And DataStax streaming offerings, again, we have Luna streaming, which is, you host your own and do things on your own, you manage all of it. Then Astra streaming is the managed side of things. So I'll kind of quickly show you too. And Astra streaming is about to go GA by the end of this month. If you're interested in being an early access participant, you're welcome to let me know. Okay, so this is just talking about Kafka. I think I already talked about it, so I won't get through this, but I just want to have a very, very quick demo. Let me very quickly show you Astra database. So this actually, for Astra database 2, we offer like $25 US dollar every month for free. If you like to sign up for it, essentially you get $300 US dollar per year for free too, and you don't need to give your credit card. So you can quickly go to astra.datastax.com, and I have all of these listed on my slide deck too, so don't worry if you don't get it right now. So you can actually sign up with that, so you can kind of click on the sign up, or in my case, I already signed up. It's also very quick to the process. Okay, let me do it again. It's essentially, you just give your email address and some information, and then you are in. That's what it is. So can we see it? It's a little slow, seems like. Okay, here we go. It's a little too big, I think. Okay, so as you can see, this is the console for the Astra database. And the thing is, we have also added in the streaming capability. If you kind of look over on the left side, if you want to create a stream, you can actually quickly do this too. So you can create stream, and all you need to do, create a Pulsar stream, is actually quite fast. Again, it supports multi-tenancy. So we kind of unitize, right, all of the tenants as calling it tenants. So you can create a name, let's say test or something, and a region, right? And you can have Google Cloud, Amazon, or Microsoft. Look at all these, right? It's all given to you for free. And you can just create a region, but I already create one, so I won't do it, because it's going to take a couple minutes, right, at least, to kind of set the stream up. So, but this is just to quickly show you how easy it is to quickly start your own Astra stream in this case, and it's all Pulsar underneath the hood. So, okay, just kind of really quickly show you too. The nice thing about this with Astra, if you use Astra database, this platform for doing your streaming, a lot of things are already set up for you quite easily. I can even kind of create different organizations to organize all of my streams. And right now, I'm also working with some third-party companies, so I have different organizations, right? So this one, for example, I have DataStax Swim. Just happened. This company is called Swim. So, for example, I already created the stream in here, and I created my tenant called POC tenant. And over here too, and that's the thing too, when you create your stream, then what to do, right? Then you can essentially go into your topic or your tenant, and then start creating things on it to make it useful. And how to do it, right? So you can actually follow this console, and then you go to the Connect tab in here. Connect tab will already give you the information about your, is it big enough? Okay, so the broker service URL, all of these are here. Web service URL basically give you the URL to connect to the admin on the command line, for example. Things like that, and you can have WebSocket URL connection as well. And then if you need a token too, it's right here. It's already created for you too. So a lot of things are quite nicely laid out for you to first start working with it. If you need all of your client information, all of these, your token, all of these things, you can download your client.conf file that will contain all of the information for you. And then if you want to create a topic, you go to the topics tab, and over here you can just add a topic, right? So, but in my case, I already have a topic called Topic Sim. And then you can create a topic. You can create it persistent or non-persistent. But the thing with non-persistent, it doesn't last for too long. If you don't use it, if you don't have subscription, it will go away. But the persistent will actually stay too. But it does have some limitation on the maximum size and time to live, all of these things, and which I won't get into all the details. But yes, if you're interested, you can create the topic. You can immediately start using it. It will have all the statistics for you here. And it shows you, too, all of your client subscription. It will display in here for you. Now, getting into writing the code, too, then you'll be wondering, how do I write the code? You can go back to the Connect tab. Over here, there are different clients that you can work on, right? Java, Python, Golang, Node.js, all of these things. I have Kafka example. So for us, right, we can go into Java, and then basically, if you want to know how do you connect, and there's Maven, guidance for you, the Maven, or using Gradle. And then how do you write a producer? We also give you like a quick sample of how do you write the producer in here. So as you can see, it's not like way too complicated. Anytime you do pops up, usually you just need to create your client, make the connection. Once you get the connection kind of handle, it's good. Then you can use it to basically create your producer. And then when it's ready, right, all of these things, as I mentioned over here, it's maybe a little small. But the thing is, by default, I'm not using Pulsar schema in here. So all of these two are basically expecting like byte array for the exchange too. So over here. But here it's just simple. I can just do a producer send, and that will send the messages out. It will publish it. Or you can do a send async too if you want to do it asynchronously. And then if you're done, you can do a producer.close and a client.close. So it's not too complicated. And if you want to write a consumer client, we also have code to show you in here too. Okay, so I realize I'm going kind of over time. So that hopefully will give you some idea. And if you want to write functions, there are also functions in here that you can create a new function. It provides you the step and guides you how you can create functions. And the sync too, over here. If you want to create a new sync, you can create the sync yourself. And then, as I mentioned to you, you can have create a sync, and you can have a sync type of AstraDB, which is Cassandra, or you can do Elasticsearch, all of these Kafka, all of these things too. And you can create your own sync as well using Pulsar IO. So that's essentially what I can show you for today. It's a little bit rushed, and I apologize for that. Let me go back to here. And at this point, just wanted to give you some information and resources. Wanted to point out to you, again, I will share the slides so then you can get access to all of this information here. Pulsar, Bookkeeper, Zookeeper, and the AstraDB. At DataStax. And this one, too, we just want to let you know, if you want to get additional $200 US dollar in credits, you can use this code open source 200 and also click on this link, too. Again, I'll share this slide so you can get to it. Otherwise, you can just go to astra.datastax.com and start creating your stream and try it out right away. And again, I have my weekly Twitch stream on every Wednesday afternoon. Usually is U.S. Central Time, so it's 7 hours behind here. So I will be trying different things out and showing you. And if you are interested, I still have some of the recordings for like a month ago if you want to visit that too. And if you want to join me too on my stream and share your project, I will be all open to it. It's all about the community that I believe. So. And here, too, if you want to join us at the hood, I call it, it's basically we have an Apache Pulsar neighborhood that anybody can join the meetup, online meetup, or there's also a wiki page, too, that you can contribute to that, too. So those are the links. And with that, I want to thank you again. I think I talked a little bit over time. Thank you so much again for coming to my talk. I hope it has been useful. And also, I wanted to invite you to connect with me on Discord server. I have my own Discord server. I have folks who connect with me. I just love to stay in touch and hear your projects and share your ideas with me. You can please feel free to give me any feedback and let me know how I can help you in your daily work as well. So thank you very much. Thank you.